In question number 6, an organic compound X, which is having a molecular formula C6H12 and O2, so means two oxygen groups are there, and it's just give an idea or indication it might be carboxylic acid or ester, because carboxylic acids, they have C double bonded with O and OH, and esters have C double bonded with O and O. So this given idea, or it might be carbonyl group and then separate OH group. There is also a possibility. But if there is an OH group of carboxylic acid, as you can see that using a data booklet, if we were having the OH group of any like carboxylic acid, then it should have a peak around 3000 for carboxylic acid, 3700 to 3200 for alcohols, and for carboxylic 3300 to 2500. But there is no peak there. Like there's no broad peak. That's why means it does not have OH group. If it does not have a OH group, it gives an idea that this might be an ester. So what Q is referring to, Q is the peak at 1700 to 1800. So this refers to C 1700 to 1800. So this give an idea that it might be C double bonded with O, like aldehydes, aryls, these groups. And then if we have a CO ester, CO is there, it will have absorption from 1200 to 1180. And you can see that R is a sharp peak. This is 1200 to 1300 between them. So 1000, so within that range, we have a peak, as this one is 1000, 1100, 200, and 300. So there is C double bonded with O is there, and there is CO as well. So using the peaks, so we can say due at Q, it's due to the carbonyl group. Identify the bonds which are responsible. So C double bonded with O, and this is CO. And then the functional group, you will mention ester. Because how you identify it's an ester, as there is no OH peak, so it cannot be carboxylic acid or it cannot be alcohol as well. Then when X is heated under reflux, dilute sulfuric acid, two organic products X and Y are formed. The mass spectrum of a Y is shown. So when basically when we do hydrolysis of the ester, ester will produce carboxylic acid and alcohol. So we got two peaks. The mass spectrum of Y is shown. So Y is having a molecular mass of a 60. Y react with sodium carbonate to produce carbon dioxide. So basically X, when we do heat under reflux, X break down into Y and Z. And this Y, it's reacting with sodium carbonate. So means it is a carboxylic acid. So Z should be an alcohol. And we already identify that X should be an ester. Which carboxylic acid? The carboxylic acid with a molecular uh, mass of 60. So which carboxylic acid is having a molecular mass of 60? So if we draw CH3, CH2, C double bonded with O and OH. So this will be 15. This will be 14, 29 plus 28 plus 17. Because like if it was example propanoic acid, so this will be 17 here, like this 17 plus 28. So that make 45. Then 45 plus 14. So it means it will be above that. 45 plus 14, it will be 59, and 59 plus 15. So it will give 74. So, but we want 60. So how it can be 60 if I have ethanoic acid? So CH3, C double bonded with O and OH. So this will be 15 plus 12, 28. So make 43 plus 17. So make 60. So this give an idea that one side of an ester is basically ethanoate is there and the other side remaining group will be there. So why is ethanoic acid? Because the molecular mass is 60. So give why react with sodium carbonate? Use information together with the mass spectrum, identify why. So why is ethanoic acid? Because it reacts with carbonate to give carbon dioxide, and the molecular relative molecular mass is 60, which is the molecular mass of ethanoic acid. Then Z has a molecular formula of C4H10 and O. It reacts with sodium to produce a gas that will be a hydrogen gas. Z is warm with a mixture of dichromate and sulfuric acid, no reaction occur. So this gives an evidence that this is a tertiary alcohol because tertiary alcohol cannot be oxidized. Deduce the structural formula of Z and explain why the equation and give the equation for reaction. So when C4, it's an alcohol C4H10O reacted, like any alcohol is there, if it is C3H9 and OH, which is equivalent to C4H10O, it reacted with sodium metal, so sodium will take position. It will produce C3H9ONA plus H2. The equation must be balanced. This is a balanced equation. The bubbles of hydrogen are there and it will produce a white solid, the precipitate. Then we have to deduce the structure of C4. So we want to make a tertiary alcohol with 4 carbon atoms. So this will have CH3, this will have CH3, this will have CH3 and OH. Why we identify it's a tertiary? Because with potassium dichromate, it does not react. Hence, we have to deduce this equation is there, then displayed. Use your answer to part A and B. Deduce a displaced formula of X. Look how to get the displaced formula of X. As we mentioned, the X, what happened to X? X break down into Y and Z, in which the Y was a ethanoic acid, so CH3, C double bonded with O and OH, and Z was tertiary alcohol. So if we recombine them, because when alcohol react with carboxylic acid, we'll remove H from here and we'll remove OH from alcohol, or other way around. OH from carboxylic acid and H from alcohol. So what will be the structure of X? So it will be CH3. It's a displayed formula, so you have to represent all the atoms and all the bonds. C double bonded with O is there. This O, you can see H and OH are being removed. Then this will be C. It will be H3. This will also be CH3 and the bottom also CH3. So this is the structure of X. Then evidence for the structure of X come from NMR, nuclear magnetic resonance spectra. Use the formula you have deduced, predict the number of the peaks, their relative area and low resolution, and state the splitting pattern in high resolution. So first, this is a structure of X. Like this is a structure we deduce. So if this is a structure we deduce, how many peaks, how many hydro environment? This is one hydro environment and this is another. So only two hydro environments will be there. This CH3 is different from this CH3. So this will be B and the other one is A. So A and B, two hydro environments will be there. Or we can say two peaks. And the relative area of the peaks, A is having 3 hydrogen, B is having 3, 6 and 9. So ratio will be 1:3 or 3:9. And then the splitting for A, when we check the neighbor does not have any hydrogen, so 0 plus 1, so A will be singlet. For B, again, when we check, any one of them you can take. So B, when you check the neighbor does not have any hydrogen, So both will give singlet. So there will be singlets. The ratio will be 1:3 or 3:9, and the number of the peaks will be 2. Next, the doubt is question 7A3 and B4. 7A1, 2, and 3. Yeah. In an experiment is carried out to determine the value for Kc. 0.12 moles of ethanoic acid were added to 0.2 mole of ethanol. 5 cm cube of 1 mole per dm cube hydrochloric acid was added as a catalyst. This contained 0.278 moles of water. The mixture was left. The mixture was titrated with 1 mole of sodium hydroxide, which react with both acids, the ethanoic acid as well as the hydrochloric acid, the catalyst. That mean titer was 45. Use the data to determine the value for Kc. So first we have this equation. Kc is equals to the product divided by reactant. So reactants, we have ethanoic acid mixed with ethanol. So CH3 COOH mixed with ethanol C2H5OH gives ethyl ethanoate CH3COO C2H5 plus H2O. First, in the beginning, initially we were having 0.12 moles and we were having 0.22 moles and water was there 0.278 moles. Now we want to find, first we need how much each of the reagents left at equilibrium, and that concentration we will use, that moles or concentration we can use to work out the Kc. First, when we had hydrochloric acid, how many moles of hydrochloric acid are added? This is a volume and concentration. So divide by 1000, 0.005 moles. Because this is a concentration is 1 and the volume is 0.005. So when we multiply, how many moles of hydrochloric acid? 0.005. So 0.005 moles of HCl. So first, when we add sodium hydroxide, the HCl will react with sodium hydroxide. The ratio between them is 1:1. So if we have 0.005, same 0.005 of sodium hydroxide will react with HCl. So what was the total volume of sodium hydroxide or the moles of sodium hydroxide added? Because 45 cm cube, 1 mole per dm cube. So this was 0.045. So 0.045 moles of sodium hydroxide were added. But out of 0.045, 0.05 moles have reacted with HCl, which was a catalyst. So how many moles of sodium hydroxide are left at equilibrium? That is 0.04 moles are left. And this remaining 0.04 moles of sodium hydroxide will react with the reagent ethanoic acid. And between ethanoic acid and sodium hydroxide, again, the ratio is 1:1. So if 1:1 is a ratio of 0.04 moles, so it means 0.04 moles of ethanoic acid will be there at equilibrium. So these are the moles which will be there at equilibrium. So moles of ethanoic acid at equilibrium, that is equals to 0.04 moles. Now, these are the moles which are left at equilibrium because, so what happens, sodium hydroxide first reacted with hydrochloric acid, it neutralized all the hydrochloric acid, and remaining of the sodium hydroxide will neutralize the ethanoic acid which are left at equilibrium. So how many moles of ethanoic acid left at equilibrium? That is same as the moles of sodium hydroxide left after reacting with hydrochloric acid. So 0.04 moles are left at equilibrium for ethanoic acid. So how many moles are reacted? So 0.01, 0.08 moles have reacted here. And the ratio between them is 0.0, because we find how many moles are left at equilibrium. So if originally it was 0.12 and left are 0.04, so how many moles are reacted? 0.08. Same thing, the ratio between them is 0.08. So same number of moles of alcohol will react, but we have 0.22 moles in the beginning, or 0.22 moles are there in the beginning. So how many moles will be left at equilibrium? 0.22 minus, or 0.22 minus 0.08, because these are the moles which will react. So when we subtract, so 0.08, when we subtract from this, um, so how many moles are left here? 0.14. Because 1:1 is the ratio, 0.08 reacted. So 0.08 reacted, same 0.08 will react. So we don't need how many are reacted, we need how many are left at equilibrium. Then 1:1 is the ratio between ethanoic acid and ethyl ethanoids. So 0.08 reacted, so same 0.08 will be formed at equilibrium. And then 1:1 is the ratio, 0.08 will form, but already we were having 0.278. So 0.278 plus 0.08, that will be 0.358. These are, so now these are the moles at equilibrium. When we have the reactant product, according to equation, if their moles are equal, total, like here, reactant side 2 moles and product side 2 moles. So we can find the Kc or Kp, which is product divided by reactant. So we don't have to convert into concentration, as the volume will cancel out. So it will be product 0.08 into 0.358 divided by 0.04 into 0.14. So when we solve this, this will give us the value for Kc, which is about 5.11, and it will not have any unit. So the next question, the doubt, this was 7A3 and then 7B4. So we have ethanoic acid, alcohol, using a percentage, use some data to confirm that molecular formula. We just have to work out ethanoic acid react with an alcohol Y to produce this ester. So C4H10 and O, we just have to work out the empirical formula, and the molecular formula will be a product of empirical formula. Then draw the displayed formula for possible structure of alcohol Y. So C4H10 and O, we have to draw 4 different possible structures. So it might be primary, it might be secondary, it might be tertiary, or it might be a branch primary alcohol. So what are the possibility? Like I'm not drawing hydrogen. This is one possibility. This is another possibility, that it might be primary, but with a branched. Or third possibility, it might be a secondary alcohol. And it might be a tertiary alcohol. This is one of the, I did not draw any hydrogen. You have to, displayed formula means you have to show all the bonds and all the atoms. But I did not draw hydrogen, just to give you an idea that there are 4 different possibilities. Then the mass spectrum of Y has a major peak of 45. Suggests a structure of 2 possible species that could make this 45. So if we are getting it at 45, so what are the possibilities? It might be CH3, CH2, COH is there, might be. So this is one possibility. So this is 15. 15 plus 14, 29. And 29 plus 17, or oxygen might be 29 plus 4, that will be 43. Because we have to identify which might be due to 45. So if it is, this can be 45. The peaks which might make 45, it is CH3, CH, because this is 15 plus 12 plus 1, 13, it will be 28, and 28 plus 16. So it will be 44, and then plus 1, 45. So this is one peak. Like this might be a possibility that this is 17. So um, this is one of the peak responsible for making it 45. Or it might be CH2 and OH. So 14 plus 14, 28, 28 plus 17, that is also 45. So these are two species which might give 45. Then you your answer to B2 and 3, identify which of the two alcohol you have drawn could be Y. So when we draw the four alcohols, their displayed formula, like it might be primary. This is not a displayed formula, this is a structural formula. It might be like a branched. It might be secondary. And it might be tertiary. So when we work out, because we want to work out which one will 45. So this is 15. Like this is 15. This will be 14. This is 14. This is 14. This is 17. And this is um, 15. This together will be there because it's linked. So CH and CH3. So this will be 24 plus 4, 28 will be there. Then this will be 15, and this is 17. Then about this one, this is 15, 14. Then this will be 28, and this 17. Then this will be together, like this is 15, but this, when it break, it will be all together. So it will be 3 carbon, 36, and then 6 hydrogen, so 42 directly it will be, and then 17. So we just simply have to check which one can give us 45. Like which two possible structure can give us 45. So the name of structure, like this is butanol, this is butane 2-ol, this is 2-methyl propanol, and this one is 1, 2, 3, the longest carbon chain. So it is 2-methyl propane 2-ol is there. Now when we check which one, like because we want to identify 45, so 17 plus 14, this will be 31, 31 plus 14. So this may make a 45 combination. Any combination here can be 45? No, like 15 plus 17, so that make 32, and 32 plus 28, that will make 60. So it won't be, even I add from left to right or right to left, it does not make 45. Does it make 45, 15, 14, 20? When I add these two, like these two will make 45. This can never make 45. So it means either it will be butane 2 all, butane 1 all, or it might be butane 2 all. So use your answer, identify two alcohols. So either it is butane 1 all or butane 2 all, which can make 45. Then complete the discrete formula of two possible esters. So we have to, because ethanoic acid is there, if butane 2 all, if butane 1 all will combine, like if you are having CH2, CH2, CH2 and CH3. So when we combine them, we remove this OH. So this will combine here. So this will be CH2, 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 CH3. So this is one possibility. And the last one, if butane 2 all is there, butane 2 all means OH is attached with the second carbon. Like we have CH3, CH2, CH2, and CH3. And then OH is here. If OH is here, this OH is removed. And this will link with the carbon chain. So the second possible structure, like the CH3 up or down does not make difference. So it will be CH3, OH is being removed. So this will be CH2, CH2, and CH3. So that is a second possible structure of ester. Then the next one, high resolution MNR, nuclear magnetic resonance is given. How many peaks are there? 1, 2, 3, 4, 5 peaks are there. So we can identify, because there should be 5 different environments, or 5 hydrogen environments should be there. So when we check which one is having the structures 5 different hydrogen environment. So this is one. There is no other. There is CH3 and it's a displayed formula. So what is the mistake here? Like I should show all the bonds and all the atoms. Keep this thing in mind whenever you draw the structure. Just to save the space, I usually draw structural formula. But in exam, when you read the question, it's a displayed formula. So you should represent all the bonds and all the atoms. So this is a second, third, fourth, and fifth. So 5 environments are there. When we check for this one, this is 1, 2, 3, 4, and 5. So both are giving us 5. But the splitting pattern will be different. Like if I say this is A, B, C, D, and E, and this one is A, B, C, D, and E. So A, B, C, D, and E. Because a high resolution is given, so I'll check their splitting pattern. So this neighbor does not, A does not have any neighbor. So A will be singlet. When I check B, left and right hand side, B's neighbor is having 2 hydrogen, so it will be triplet. C neighbor, 2 here and 2 here, so it will be 2 plus 2, 4, but n plus 1, so it will be quartet, quintet, because 5 are there. It will be quintet. And for D neighbor, 3 and 2, so it will be sextet. And 3 neighbor are E neighbor are 2, so it will be triplet. But when I check for this one, A neighbor, so it will be singlet. B neighbor is double, so it will be triplet. C neighbor are 2, so again it will be triplet. D neighbor, one side 3, another, so 6. And E neighbor are 2, so it will give us triplet again. So how many triplets will be there? 3 triplet. Here we'll have two triplets. So the simple way to identify if there are three triplets, it means this is a spectrum will be correct. Like this structure in which butane 2 all react with carboxylic acid will be correct. But if there is only two triplets, then it means butane 1 all is reacted. So when we check if the number of the triplets, so five different hydrogen environments are there. So they give us the relative peak 1, 2, 3, 4, 5. When we draw the structure for A singlet, for B CH. Oh, okay. There's a small mistake here because there should be H here, not H2. It should be H. So because as you can see, three bonds are already formed, so there should be one H will be there. So if B neighbor is one, so this will not be triplet, this will be because n plus one, so it will be doublet. And for D, for C, it is triplet, correct? So singlet, doublet, triplet. For D, it is 4 plus 1, so it will be quintet. 5 will be there. So D will be quintet and E will be triplet. Neighbor, yeah, E neighbor are 2, so it will be triplet. So we should have two triplets, one singlet, one doublet, and one quintet. So how many peaks? This is 1, 2, 3, 4, 5, 6 are there. So neighbors are 7. The high resolution NMR of ester Z is shown. The relative number of the proton causing the peaks, the using NMR to determine the structure formula of Z, that is consistent. Draw your formula below and label responsible for the peaks. Z, if we were having butane 2 all, so when I draw this possible structure, because we have to check, we have to draw the structure which is consistent with this. So it was ethanoic acid was there. So ethanoic acid was reacting with butane 2 all. So if it was reacting with butane 2 all, so this will have 3 hydrogens. This will have 1 hydrogen. This will have 2 hydrogen. And this will have 3 hydrogen. When we check the number of hydrogen environment, this is 1 hydrogen environment. So this should give a singlet because neighbors, 0 neighbor. This is another hydrogen environment example. We don't say B, then we'll identify. So this should also give us the neighbor is 1, so it will give doublet. This one, okay, I did not count this one. So this one, neighbor 3, 4, 5. So it should give 6 peaks. Excellent. This one, neighbor 3 plus 1, 4. So it will give 5, quintet. And this neighbor are 2, so it will give triplet. So we'll have singlet, we'll have doublet, we'll have quintet, like 3 peaks. So this is, as you can see, so A is giving 1, 2, 3, 4, 5, 6, like split into 6. So mean this is A. B into singlet, so this means this is B. C 1, 2, 3, 4, 5. So 5 is quintet, so this is C. Then D is doublet, so this is D. And then E is triplet because the neighbors are 2, so E will be triplet. So this is a structure of, this is a possible structure for this compound. Is it clear? Using a high resolution NMR and the information the previous part, we work out the structure of this compound. So I have discussed the first 7 questions. And the remaining I will discuss in the next session. So 7 we have discussed. It's about few questions are left. So that in the next session I'll discuss.